Hello everyone. So we're at topic 7. Thank you so much for joining me and lending me a bit of your time. What we're dealing with topic 7 is fire separations and fire resistance ratings, or FRR for short. You reached this topic because you clicked on the link that was in the course notes you found on Brightspace. Make sure before you do anything else that you download those course notes to your device of choice. That way you're not relying on Brightspace to access your course notes. You never know when you'll lose access. Let's do this. We're touching on this because in topic 5 we started talking about levels of safety. Remember the combustibility of material and fire resistance rating? The combustibility of material was a measure of how well a material burns or not. Whereas the fire resistance rating, or FRR for short, it's a measure of time, of how long a material burns for if it is combustible. Okay? We're going to dive a little bit more into these two topics with this topic, topic 7, like I promised you we would in topic 5. Let's do this. Okay. So we're going to first start distinguishing between combustible construction and non-combustible construction. And I'm sure at this point you have an opinion as to what the difference is between the two. But we're going to see what the building code says is the difference between these two topics, okay? Because it is important. Now, to do that, we have to go over a whole bunch of definitions like combustible, combustible, non-combustible, combustible construction, non-combustible construction, and then fire separation and fire resistance rating, right? The building code provides definitions for all of these things, so we're going to go through them ourselves. I know exactly what you're thinking, right? You're going, oh, goodness, more definitions. And I agree with you. By now, we're at topic 7. By now, you know exactly where to find the definitions for these words in the building code. If you don't, you've missed the last 6 topics. You want to go back and review them and reread them because I explain exactly where in the building code to find definitions. So I'm not going to read definitions for you about these words because they're already written in your course notes. I'm going to give you a high-level overview of what they mean, okay? And let you find the definitions. Let's do this. Let's pretend, first of all, that we're in a crazy mad scientist lab. Okay? Play along. And we're going to start by describing what combustible construction and non-combustible construction means. Super easy. If, let's see, what's the best way to say this? If your construction does not meet the requirement of non-combustible construction, then it's combustible construction. Clear? No? Good. We're in the same place. But that's the definition for both combustible and non-combustible construction. It's basically based on each other. Right? So it basically is based on the definition of non-combustible materials. So let's figure out what non-combustible materials are. Okay? Ready? We're doing non-combustible materials and combustible materials. What do they mean? Simple. There is a test or a series of tests that decides or determine whether a material is combustible or non-combustible. Okay? If that material you're testing passes the combustible material testing, it's considered combustible. If it does not pass, it's considered non-combustible. And therefore you can figure out how to define combustible and non-combustible construction. But go find these definitions. Okay, where else are we now? Fire separations and fire resistance rating. Ready for this? These are easy. A fire separation is basically just a barrier to fire. There's more in the definition, so go find it. What's a fire resistance rating? I alluded to this in topic 5. It's a measure of time. It's basically a measurement of how long a specific type of combustible or non-combustible material will resist fire. And this is important because in the building code, you're going to find that there are requirements for fire ratings to last a certain amount of time. As you can see here, everywhere from 20 minutes all the way to 4 hours. But ultimately, it is up to you to go find these in the building code. They're listed for you on these lectures and in the course notes, but you must go look for them. Especially when you look at something like Article 3.1.5.11, which talks about how to use non-combustible construction by using combustible material. Yes, go look it up. Okay, so that was the definition part, but I think let's learn by looking at reality. What I've put up for you is a drawing of the ACE building. It's drawing A20. And I've uploaded this drawing for you on Brightspace. Wherever you found these course notes is where you're going to find these drawings. Okay? Nice and simple. Okay, so we're going to zoom into this part of the ACE building. Okay? And this is what that zoomed portion looks like. Okay, you can sort of see where the student pods are here to study. Okay, here is what used to be a resource library has now been turned into a class, and here is where the student success specialist office is. Okay, all right. Now, do you see these stairways? You know these stairways if you've been to the ACE building. Well, you see how they're marked with dash, double dot, dash? Well, that's what a 1 hour fire rating has been illustrated as in the drawings. So that means those walls and those stairwells have been rated to be 1 hour fire rating. So if there is a fire inside the stairway, it should not get out for an hour. If there's a fire outside of the stairway, the people in the stairway that are trying to get out should be safe for at least an hour. Make sense? So now go look on Brightspace because I've uploaded A20 and A21. You can check out, these are the actual drawings for our ACE building related to fire ratings and fire separations. Go check them out. Okay? Alright. Now, the fire resistance rating of any separation is based on pre-testings of materials and assemblies. We've touched a bit on this. And the approved sources for it are the ULC, SB2, and SB3. The ULC is a document that is produced by the Underwriters Laboratories of Canada. You can purchase it from them, and it relates to Part 3 buildings and to Part 9 buildings. Okay? We're not going to use it, but you should be aware of this, and we'll touch on it on what it looks like. SB2 and SB3 are the supplementary standards SB2 and SB3, which you found in Volume 2 of the Building Code. Okay? One of them is called Fire Protection Rating. The other one is called Fire and Sound Resistance Rating. Okay? So these are the two that we're going to touch on a little bit today as well. But before we get to that, I want to discuss a little bit what the ULC looks like. Basically, it's like an IKEA catalog. Okay, so you can flip through this when you have the ULC document, and you don't have it, I know that, but I just want you to be aware of it because you might be using it if you're in the business. Okay, and you can flip through it, and like I put up for you on the screen and is in your course notes, you basically are going to see different assemblies. So the assembly that you see up here right now, it's a wood stud partition with a 45-minute fire rating, and it tells you exactly what it's made of, how to achieve that 45-minute rating. They're basically pre-tested assemblies to those specific fire ratings. So you flip through this catalog until you can find the fire rating that you're looking for, and that's how it works. So for example, here I put up a wood stud partition with a 1 hour fire rating. I flipped through the catalog and found this one. Okay? And the construction is also shown on the screen and in your course notes. Lastly, I think I have one more. Yes, example 3. I think this is a non-combustible partition made of steel studs. And that too, I flipped through the ULC catalog and came up with this construction. That's simple. Okay? The ULC is basically an IKEA catalog of construction assemblies with fire ratings associated with it. Okay? Another place that you can look at is the CGC handbook. Okay, I've linked it here and it's in your course notes as well. It's another place that you can get fire assemblies, but we're not going to use them. Okay, not too big of a deal. What we're going to be playing with is the supplementary standard number 2, SB2, fire performance rating. Okay? And specifically, we're going to deal with section 2.3, wood and steel framed walls, floors, and roof. We're going to use the component additive method for it. Okay? You want to make sure that you read these. All right? Starting with article 2.3.1. And that's because this tells you that you can use this component additive method in SB2 only up to 90 minutes. You cannot create fire separations that are more than 90 minutes in fire rating. Also, Article 2.3.21 talks about the difference between load-bearing and non-load-bearing type separations. Okay? I'm not sure if you know what the difference is, but a load-bearing type structure is a structure where if you knock it down, more of the structure in the building comes down. A non-load bearing one is a type of structure that if you knock it down, nothing happens. So an example, on the top story of your house, typically all the walls except for the exterior walls of the top floor of a house, typically are non-load bearing. That's why it's easy to remodel the top story of a typical house in Canada, to add a bathroom or remove a bathroom or make rooms bigger, because none of those walls are load-bearing. You can knock them down and the roof is still fine, because typically the roof sits on the outside walls. Okay, another thing that's important and you need to remember, SB2 applies to both Part 3 and Part 9 buildings. Okay? All right. Let's talk about this method of calculation, the component additive method. Basically, the way it works is that you're going to have a whole bunch of tables. Okay? And I've listed them here for you. The first set of tables relates to the membrane that's exposed to the fire. Right? So if you have a fire, the side of the wall or floor or roof that's exposed to the fire, these four tables, contain details about the fire rating of that membrane. Then to that, you're going to add the time for the framing members. That's the structure that's right after the fire. That's the structure that's after the member. And you're going to get it in these two tables. Okay? And lastly, you're going to add any extra time because of additional protection that you find in this table. It is literally an additive method. Okay? And you want to review also these two articles, please. Now, this component additive method might sound, what? When I discuss it with you. But really, it is nothing more than really making a hamburger or a sandwich. What I mean by that is a hamburger or a sandwich has different layers to it. Okay? A bottom layer, then a whole bunch of stuff, and then a top layer. Or if you want to look at it in a different way, there is a layer that's closest to the fire, and then there is all the other layers of the walls or roof or floor. It's like a sandwich or a hamburger, okay? And every layer may contribute a certain amount of time to the assembly of the whole thing. That's why it's called the component additive method. I think I've talked enough. Let's learn by doing, okay? Here, we have an example. It's in your course notes as well, and it's let's see, a wood stud wall spaced at 400 millimeters on center, or 406 millimeters on center. Okay, that's 16 inches. And you're being asked to figure out a setup where you have a minimum fire resistance rating of 1 hour, 60 minutes. So I've reproduced for you at the top of the screen a little bit of table 2.3.4a and a little bit of table 2.3.4e. Okay, now you want to go to your notes, to your building code and find these tables so that you know what I'm talking about. Okay, you don't want to rely on just looking at it from here because these are just partial, small parts of the table. Okay, basically we're told we want to figure out a wall. Okay, it's load-bearing wall. It's made up of wood studs, and the spacing of these studs is 400 millimeters on center. Okay, so we have to do this in layers, right? Like our hamburger, our sandwich. And we have to start with the first layer that's facing the fire, and that's table 2.3.4a in this case. So what we're looking at then is we want to come up with 1 hour, 60 minutes of wood studs. And we have a choice of 12.7 Type X gypsum board, and that's 12.7 millimeters Type X gypsum board, 15.9 millimeter Type X gypsum board, and double layer of 12.7 Type X gypsum board. So, and then we have to add to that the structure of the wall, which is wood studs. So it looks like from table 2.3.4e, we're only looking at wood studs. Okay, so the combination of these layers of gypsum, which is the correct term for drywall, okay, gypsum board, is probably to do something like this, right? The 15.9 millimeter Type X gypsum board and the wood studs at 406 millimeters on center, right? Because we're told that the spacing has to be 400 millimeters. And that looks okay because 40 minutes of the 15.9 Type X gypsum board and 20 minutes of the wood studs at 400 millimeters on center gives us 60 minutes. That's good, right? Make sure you go to the SB2 to look at this, okay? All right. So that looked fairly easy. I basically added two different things from two different tables, which I reviewed in SB2. Let's try another one. What about this example here, where you're told to figure out a load-bearing metal stud partition with that spacing and a fire resistance rating of 1.5 hours, 90 minutes. We can do that. We're allowed to do that. Let's try that. I see, by looking at tables 2.3.4a and 2.3.4e, this combination... Oh, wait. What's happening here? Look at this. Yeah. So we have a problem, don't we? The highest amount of time that we can get from the first layer, the membrane from table 2.3.4a, is 50 minutes for a double layer of 12.7 Type X gypsum board. And we're only allowed to use steel studs. So we can get 60 minutes at most. We cannot get 90 minutes for this type of wall. So we can't actually make this work. Okay? So this is the case where we would go to the IKEA catalog of fire ratings, because with the component additive method, this won't work. So go to the tables and check this out, okay? Let's try one more, okay? Yeah, so here I was just making a note that we were looking at the metal studs, and that it's going to be load-bearing, and that the spacing was going to be this. Okay, let's try an extra example. It's not in your course notes, it's only in your video. Okay, and we're very close to the end, I promise. We're going to look at a non-load-bearing wood stud partition, and we want to achieve a fire resistance rating of 60 minutes, 1 hour. So I'm still using the same two tables because I want the bare minimum, okay? And it looks like that I can do it if I can connect the Type X gypsum board, the 15.9 millimeter Type X gypsum board, with the wood studs at 406 millimeters on center, right? That should work because that would give me... Oh dear, what's the problem here? Here's the problem, okay, which is very important. We talked about it when we were talking about fire separations. If you go to table in SB2, 2.3.4a, and you go and check out what it says for non-load-bearing walls, 15.9 Type X gypsum board, you can only use that 40 minutes for steel studs, not for wood studs. So this, what I propose to do here on the screen, not acceptable. It's impossible. The building code doesn't allow you to do it with the component additive method. So again, here's another example. So make sure you review these tables because the entries in these tables have these little numbers. So in this case, 15.9 millimeters Type X gypsum board, 40 minutes. You'll find a little number like an exponent next to it. Might be a 2 or a 3 which points to a note beneath that table that explains you can only use 40 minutes with steel studs. Alright, I think you get the point, but go and check it out. Now let's talk about SB3, Supplementary Standard 3, which deals with fire and sound resistance of walls. It has table 3.1 and 3.2. One of them is for walls, so vertical members, and 3.2 is for horizontal members, so that's floors, ceilings, and roofs. Go check it out because the course notes explains it very well. I don't want to take too much of your time because we're coming up to about 20 minutes now. Here's one thing that's really important. SB3, which is kind of like another IKEA catalog, check it out, only works for Part 9 buildings. Okay? Alright. I think we're getting very close here. Yes, this article of the building code says that whenever you have sprinklers, according to this article, you can forego any fire resistance rating. Okay, but sprinklers are really expensive. So, alright. And lastly, that in some cases, when you have a wall that's at an angle, or you have a ceiling that's at an angle, or a roof that's at an angle, when is one a wall and when is it a roof? Another way to look at it is this. When does a wall start being a roof if it's at an angle? Or when does a roof start being a wall if it's at an angle? This article of the building code explains that very well. Okay? It's also linked for you in your course notes. Go check it out because this, I think, would make a great test question. Okay? That's it. Thank you so much for your time. I'm sorry this was a little bit of a longer video. I appreciate your attention. Make sure you download the course notes to your device of choice and take care. Do the homework. Bye.